In the previous section, we talked about the 5 program steps that you can use to overall design on the program. What we want to do in this particular instance is present a little more formal way that you can design the classes themselves that will be part of that larger program. Now, there's been a complete body of literature developed on UML, which is Unified Modeling Language. And we really don't need all of that detail for us to find something that's useful. So what I'm going to use is something that I call UML Lite. And we're going to skip over a lot of the details that I think get in your way. So we're going to do a version of the Unified Modeling Language, but we're going to leave out some of the details that we don't necessarily need. UML is a standard way to model objects in object-oriented programming. And that model is a stripped-down version. There are, like I said, multiple books that you can study if you wish to get the full flavor of it, but this will work for our particular purposes here. There are 3 basic parts to a UML diagram. The class that you're going to model using UML Lite is basically a name, a list of the properties, and a list of the methods. A more complete version of UML will also have a 4th element, which is one that's called persistence. And by persistence, they mean are the properties and methods and the name going to be persisted to a data file or a database or something like that. And we can abstract from that for our purposes here. If we wish to model a class, like we're going to model one called class dates, we can use the minus sign in the UML diagrams to represent a private access specifier on a piece of data or a method. In other words, if you see a minus sign in front of a class name or a method variable, that means that it retains the private access specifier. If you see a plus sign in front of an identifier, that means that that particular item has a public access specifier. Now, if you'll recall from our earlier discussions, we said private means that it's a scope thing and its visibility is limited to the point in which that particular item is defined. If you see a plus sign, in essence, you can think of that particular item or method as having global scope. And we can give you an example here of what class dates might look like. In the little diagram on the right side of your screen, at the top you'll see the name, and I always abbreviate a class with CLS as the intro to it. So we have class dates is the name that I've assigned to this particular class. Inside of that, if you look at the extreme right side of that diagram, you'll see that we have a list of properties. And in this case, we have year, month, day, days in month, leap year, and current date time. And in front of every one of those, we have a minus sign. And if you look over on the left side of the slide, you'll see the minus sign means that we are assigning all of those the private access specifier. What that means then is that we are limiting the visibility of all of the properties in this particular class to this class itself. We are not going to expose those pieces of information to the outside world directly. Contrasting, look at the bottom list in the little pictorial as methods, and you'll see that we have 2 methods, get leap year and get Easter. But note that both of those have a plus sign in front of them. So what that means is that these particular methods have a public access specifier. What that means then is that the method called getLeapYear is going to be exposed to anyone who wants to use this class. And the user in this case is going to be another programmer. So when you hear me talk about classes and the user of the class, I'm not talking about the end user who runs the program. I'm talking about the programmer who wants to use this particular class in writing some code. So both of the methods are prefaced with the plus sign, which means that they have the public access specifier. And because of that, this is going to be what forms the user interface for our class. And that makes sense if you think about it, because this is the only way that the outside world is going to be able to get at the data that is buried inside of this class, is through these public user interface methods. Now, what I haven't shown here are any of the other types of methods that are possible in a class. We talked about this earlier, and we talked about general methods and property methods and helper methods and constructor methods. In this case, these two methods are what we would call general methods. These are methods that you've written to solve a particular task, and we can tell by their name it's probably going to be to determine whether a specific year is a leap year or not, and the second one probably is going to tell us what the date is for Easter. Now, you'll notice that we also specify a parenthesis in the method, followed by a name, followed by a closing parenthesis, a colon, and an int. Now, what that means is the signature for the leap year method, it expects a year to be passed in as a parameter to this particular method. The colon is a separator saying that specifies the signature for this particular method, and that the method is going to return an int. This is different than the way most libraries in Java, C#, C++, and so forth work. We are going to write a different get leap year than is currently available in most libraries. Most of those return a Boolean that's either true or false, meaning that the year is or is not a leap year. We're doing this for a different reason that I'll explain later on, but we are returning an int. If we were writing it to be consistent with the other versions of get leap year, this would be returning a bool. Easter also has a year passed into it, but it returns a string. So it would appear then that we're returning a string from get Easter that will tell us the month and day of a particular Easter. There are 4 general types of access specifiers that we can use here, but we're only going to look at the 2. Public, which we've talked about earlier, and that means that it is available outside of the scope of the class itself. As you'll notice on the slide, it says this is not a good idea for class properties. Well, it's not only not a good idea, it's a terrible idea. Because if you expose class properties directly by giving them a public access specifier, you are violating the first leg of the object-oriented programming trilogy, which was encapsulation, if you'll remember that. So you don't want to use the public access specifier on properties. And I would almost say never use it. Always rely on the default access specifier for a property which is private. However, you do want to use the public access specifier for those methods that you wish to expose to the outside world, because those public methods become the interface that the outside programmer uses to access your code in the class itself. So it becomes the interface of how the outside world is going to communicate with your class. So public access specifier must be used for any element of your class that you wish to form as part of the user interface. Private, as we said before, it means that that given data item or method is going to be visible only within the scope level of its definition. For class properties, since they're defined at the highest level within the class, it means that that particular property is everywhere visible within the class itself. However, outside of the class, it's invisible. Indeed, no one would know that it's even there. It's good for the methods. The private access specifier is good for those methods that you wish to use internally, but don't want to make part of the public user interface. We called those things earlier helper methods. They're designed to make your life easier as a programmer for the class, but you don't want to expose them to the outside world. Now, using our class date class to define an object is really a 2-step process. It's quite simple, actually. The first is the statement class date and then my date, semicolon, forms, as you should know by now, it really forms a data definition. We are forming a definition of the variable named myDate. The data type for myDate is of type class date. The statement does cause a symbol table entry for my date. It does allocate 4 bytes of storage, so it is a data definition. But the important thing is that it does not fill in an R value for that variable. And indeed, the Windows operating system, as will most other operating systems, will initialize my date to have a value of null. And as you know, null means that nothing of any use can be stored here. So now we have a 4-byte bucket that is really currently empty. All it has in it is the value of null. Now let's add a second statement to that. And let's say my date equals new class date, paren, semicolon. This is where we go from a definition of a pointer to an object to the actual data itself. In other words, what we're now doing is we're calling the constructor in the class date class to set aside a block of memory that's big enough to hold everything that we need to work with a class date object. So really, this second line performs an operation that almost any programming book will call instantiation. When we're done then, we take the class date cookie cutter, we stamp it into a hunk of dough called memory, and we end up with a myDate object that's been initialized by the constructor for that class. You now have a variable of type class date named myDate that is usable in your program. So it's this second line that actually causes the instantiation of an object. The first line simply tells you which cookie cutter to grab off the wall. You grab a class date cookie cutter. And the second line tells you what type of cookie you actually end up with. You end up with a myDate cookie that looks like a class date object. So the bucket then becomes filled in, the myDate bucket becomes filled in with an R value that is the memory address of where all the data for this class are stored. In this particular case, the myDate variable. When we walk away then from that second line, we have a variable that points to all of the properties that are associated with this particular object. Because we now have an object, we've instantiated the myDate object, we can use that in our program in any way we want. Because programmers are inherently lazy, they will take those two statements and collapse them into a single statement. And that single statement looks like class date, myDate equals new class date. And actually, that's not really being lazy. Fewer lines to do the same job, especially if they aren't fuzzy or tricky code, makes sense. It takes up less real estate on the text editor that's entering the program. It collapses two statements into one. I doubt if there's any real efficiency, so don't think of it as a compiler efficiency. It's simply the way it's done. This is a normal way that a programmer will write an instantiation of an object. What I'd like to do at this point then is take a break from the slide presentation and go to an actual demo where we will type in the code that will show you how all of this fits together. So we're going to load up a Visual Studio program and implement our class date with the leap year method as part of it. What I've done is I've started a project under Visual Studio, but I'm going to try and make this presentation as language inspecific as I possibly can. So I'm going to actually end up undoing some of the code that Microsoft writes behind your back to make the transition to any other language that you might be using a little bit easier. So what I've done is, you can tell over in the design component, the Solution Explorer, I've created a sample project called Date Sample Project. And in doing that, Visual Studio automatically creates all of the sub-files that you see here, including this one called Form 1. And that's the standard Windows form. I find it very useful in writing object-oriented programming examples or code to use certain names for certain files. And any file that contains the starting point for a object-oriented program, I tend to call form main. And the reason is Java, all of those use a form main. So I'm going to rename this form to form main. And I want all other references to it changed. So now I have form main, and I also have a form main design module that's created as part of that. Again, Microsoft in the background wrote this thing called program.cs. I don't even want that, so I'm going to get rid of it. Well, I'm going to just get rid of the whole file. So right-click on it and delete it. We don't need it. Now I'm left with the code in the form main project, and I'm not going to let you use that either. I'm going to get rid of that. The first thing that we want to do is to type in the files that reference objects that are integral to the programming environment. For the Windows environment, that's the system object, and it is from that particular object that literally everything in the Microsoft background is built. We talked about thinking of classes as cookie cutters. If you look at all of the objects that are derived from the system object in the Microsoft programming environment, you have about 4,000 cookie cutters hanging on the wall that you can pull off and use in your program. For that reason, because it is so deep, they break it into subsystems to make it easier to reference those parts that you're really using. So one of them that we want to use is the Windows subsystem, and from that we want to use the Forms subsystem. So what we have now are the two primary modules, libraries that we will be using in this simple program. The next thing that we want to do is to go over, look over here in the Solution Explorer, we have the form main, and that's what we're writing in now. We can see that up here on this tab that we're adding code to this particular file. So we need to give this a name, and like everything else, it is a class. Everything in an object-oriented program tends to be a class. This just happens to be a special one because it hosts the starting point for our program. So we're going to give this a public access specifier. We're going to tell the world that we have a class, and we're going to tell it that its name is form main. Now, form main by itself has no functionality yet. We've only got 4 lines in this program, but we want it to behave like a Windows program. In other words, we want to inherit all of the functionality that a Windows program has without writing all the code for it. And that's why we put in line 2. What that's really saying is go to the Windows class libraries and pull out everything that has to do with a Windows form. Now what we want to do is to say this particular class is an extension of those forms. So we're going to type in form. And what that does is it tells the compiler that form main is going to have code of its own, yes, but it's going to stand on the shoulders of all of the forms that Windows generally is capable of producing without writing the code for it ourselves. Again, this is one of the reasons that you do use object-oriented programming, is because you can import and use all of those classes that have already been written for you. Now what we want to do is to write a method, and this is standard to Windows, and we want to make it a private method. It's not going to return anything, so we're going to use the void type specifier, and we're going to call it initialize component. And that's going to be a method. And right now we're just going to leave it as an empty method. Then we're going to go after that, and we know from previous experience that Windows is going to be pretty busy writing stuff behind our back for that particular method. So what we want to do is to tuck that away so we don't have to look at it all the time. So what we're going to do is we're going to say, okay, let's forget that and tuck it away in a region directive. So now anything that has to do with initializing a component, we can click on that region specifier right here and hide it. Or we can click on it and take a look at it if we need to. So the pound region, the pound end region is simply a way that Microsoft allows the editor to hide lines of code, which is nice because that frees up more real estate for you to use with the code that you're really going to be concerned with and the code that you're going to be writing yourself. All right. Remember how I said that every class has a constructor? One of the characteristics of a constructor is that it shares the name of the class. So we have a public constructor named form_main. And all we want this constructor right now to do is to initialize the components that we're going to put on the form. So we're going to call that method that we just wrote. And that's all we want this particular method constructor to do. We're going to put in this is going to be specific to Microsoft's implementation of the language. Sorry, I misspelled that. It should be stat. If you're writing a program that does not involve threading, it's a good idea to put stat thread at the top of it like I have here, fairly early in the program. If you're writing a multi-threaded program, that thread changes to mult-thread. We're not going to cover that, but I'll just point it out in case you want to look it up. There's documentation online if you're writing multi-threaded applications. But I think it's a good idea. The program will run without that. But you'll find that if you develop a program in Visual Studio and later change it to a threading program, you cannot change that particular line, what you see on line 17. The compiler, for some reason, is incapable of changing that, and you can't change a non-threaded to a threaded program unless you have that particular line in it. So I just put it in by habit, even though I may never use it. The next thing that we have to add to this file is a public static method named main. Now, as you know, most programs, Java, C#, there's some others, have to have a main program to mark the start of the program. In other words, the method named main with a capital M denotes the point at which this particular program begins execution. We don't have anything defined yet to run. So the first thing that we have to define is a form_main object. By the way, this is sensitive to the way you spell things. We use this particular line to instantiate a class object named main of type class form_main. So in other words, what we have here at the end of this particular line is the instantiation of an object named main that is going to be of the class that you see defined on line 4. It's going to be a public class form_main. All right. Then all we need here is to tell it we want to run the application using the main object. All right, so far that's what we have. Every program that I write when I use Visual Studio begins with this set of 23 lines. and I build from that. So I actually end up creating a template, which I call C# template, that contains nothing but these lines. And the reason is because I know that every program that I create has to have these particular lines and statements in it. So I just write them in a notepad file, and then I just pull it in with a copy and paste, and I'm done in a matter of seconds, what took several minutes here.